actual x values are. But the delta x is the width of each rectangle. So, what is f of x sub I? If I have some things here, this is getting more and more confusing, I think. I hope it's not, but, you know, you can figure it out. These, I don't know what these are. This is like, let's say, x sub I, let's say that x sub 0 is 0. I'm making that part up. And then we'll say that this part is x sub 4. Alright? So, and we don't know what these values are, but that's what we're going to, I'm making that up, making that part up. And this is f of x. So that's our function. So, what is then f of x sub I? That is the height of each rectangle. So this is the width. Delta x is the width. This is height of each rectangle. How does that even make sense? How does that even make sense? Okay, so if you take f from the graph and you plug in x sub 0, you get out this y value. Well, that y value is the same thing as that distance right there. So if we're doing this y value times delta x, which we don't know for this, it would give me this rectangle. So that's what I would get. This distance there is delta x. And then let's say x at this point, let's say it's x sub 1. So then f of x sub 1 would be here. Right? I shouldn't do that. F of x sub 1 would be here. F of x sub 1. It's the y value, but also that means it's the height. So I draw that over. X sub 2 and so on. They give me all the heights of my rectangles. And the width is also always going to be delta x, so we'll leave it like that. So these are heights of my rectangles. And you get them by plugging in the different x values. So, what am I saying? Yeah. There's a different heights. I hope you know what that means. I don't know. In this case, in this problem, the heights of my rectangles are going to be f of 0.5. So really what I'm doing here is I'm looking for f of, and then my delta x is going to be 1. So I'm looking for f of 0.5 times 1 plus f of 1.5 times 1, f of 1.5 times 1 plus f of 2.5 and so on. Because f of 2.5, that's the height of this rectangle, and the width of this rectangle is 1. So all I'm doing then, I know that this is what I should get for the actual summation, f of 3.5 times 1. This video is being too long. I might have to split it into two parts. What am I doing? So I'm just looking for whichever summation gives me this, and I just plug stuff in my head. F of x is, they tell us, 4 over x squared plus 1. So really what I want is, there's the 4, this would be the x squared, and then the 1. So really all I'm looking for is when the x value is 0.05, and then the next one has to be 1.5, and then the next one has to be 2.5, and so on. So I just start evaluating things for n. If I plug in n equals 1 to this one, I get 4 over 0.5 squared, or 0.5 squared, plus 1. That is f of 0.1. Great. Fantastic. All right, what's the next n value? That would be n equals 2. 2 times 0.5 is 1 quantity squared plus 1 over 4. That would correspond to f of 1, but I wanted f of 1.5. So that's not work. This one does not work because not all the values work. And I just keep doing that, and I keep checking for all of these. And it turns out that, what did I say? The third one? Fourth one? This one? The second one. Let's try the second one. Plug in 1. 1 minus 0.5 is 0.5. Very good, very good. Squared plus 1 over 4. That corresponds to f of 0.5. And then the next value would be n equals 2. 2 minus 0.5 is 1.5 plus 1 over 4. And that is the second value. And I think it's going to work, but you can plug in n equals 2, n equals 3. 3, that'd be 2.5. 3 minus 0.0 or 0.5, and so on. So it works out. B is the answer. There you go. You just look at the graph, figure out your sum, know that summations mean that, and well, there you go. There you go. You know? You know? You know? Do you know? I don't know.